Okay, so let's take a look at the zero product property. So the word zero is just the number zero, and product means multiplication. And, if I read through the words, if the product of two factors is zero, so if you multiply two things and get zero, then at least one of those must be zero. And if I write this with symbols, for any real numbers a and b, now take your pencil and cross this out. If a, b, meaning a times b, equals 0, then either a equals 0 or b equals 0. Sorry about that, these things print weird. And so below here I say, let's rewrite this. So let's rewrite that the product of some number times another number, if the product of those two numbers is 0, then either a has to be 0 or b has to be 0. So get that written down in that space below, and now I'm going to do a little bit more thorough explanation. So what this means is that if I have x times y and I get 0, well, the only way I can multiply two numbers and end up with 0 is if either this is 0 or either that is 0. And the cool thing is, this can look even uglier. So let's pretend instead, well, we agree x can be 0. But what if y was instead something like x squared minus 1? Well, then even though there's parentheses going on here, this whole thing would be pictured like it was just some value being multiplied by x, which means this would also be able to be 0. So there's all kinds of different ways to now solve equations that aren't just limited to having the form mx plus b. Now it means that if we have something with the squared term, maybe we can factor these and figure out how they work. Solving equations. Check your solutions. Now this problem is already given to us in a factored form. And because of the way it looks, I know that I have multiplication of two things resulting in 0. So that means that either the left side, which is x minus 5, is 0, or the right side, which is 3x plus 4, is 0. And the best way to do these is directly below this line, we're going to rewrite x minus 5 equals 0. And then over a little bit, we're going to write 3x plus 4 equals 0. Now you're just solving equations. We're going to add 5 to both sides, which is going to result in x being 5. I like to box them. Over here, I'm going to subtract 4 from both sides, leaving me with 3x is negative 4, and dividing both sides by 3 gives me x is negative 4/3. And I don't bother turning that into a decimal. But as a final step, I want to see this written in one line of math, and maybe we move down a bit, or maybe we write this off to the side. So I'm going to write x equals negative 4/3, comma, 5. I separate this by a comma to indicate that there's two possible solutions to this. Now, it says check your solutions, but we're going to do this in our heads. So let's first try the easiest option of the two. I'm going to plug 5 in here, and sure enough, 5 minus 5 gives me 0, which means that 0 times whatever this is would work out, and I would get 0. If that check is too quick, we can talk about those. Now the other thing I have is, negative 4/3. So, dang it. So now I have negative 4/3. So I'm going to actually write this one out, but we're going to do this in our heads. 3 times negative 4 over 3 plus 4. 3 over 3 would go away, and then negative 4 plus 4 would be 0. So that checks out as well. And you get to the point where, you do enough of these and you can kind of picture all this business. Pause to look at this for a moment and compare it to the one before. This one is not factored. And I'm going to go into what if you're taking a test? So let's imagine later on down the road, and now you have all these different things. X squared equals 7x. You know what some people try to do? They're just like, well, what if x is 0? I'm just going to guess. Well, 0 squared would be 0, and 7 times 0 would be 0. So cool, great, we got an answer. But these radicals, I'm sorry, not radicals, these exponents mean we probably have two solutions, so that wouldn't be enough. So trial and error would work. Now, sometimes people like to try to divide by things. Well, you know, here I am dividing by 7, and I'd have x squared over 7 is equal to x. Well, that didn't help. So it's kind of weird. You have to be able to get the variable by itself on one side. So the best way to go about this is I'm going to take away 7x from the right side. I'm going to take away 7x from the left side, and then I'm going to have x squared minus 7x is equal to 0. Until you have 0 on the right side and it's by itself, or on the left side, you can't solve these. So whenever you're dealing with exponents, these work out thanks to the zero product property. So your goal is to be able to get something in a factored form equal to 0. Okay, we got x squared minus 7x. Now we're expected to apply all that knowledge from this section. I look at this, I see two terms. It's not a trinomial. It's not a grouping problem. But they both have a greatest common factor of x. So I'm going to factor x out from the left, leaving with me with x. Minus 7 is equal to 0. Once I have this, I can solve it. Well, the easiest part is just to immediately say, well, x is 0, thanks to this variable being there. I'm not showing all that work for it. I just know that that left value gets figured out. But over here I got some room, so maybe I show x minus 7, because I'm pulling this chunk out, and I know that that also could be equal to 0. Solving this, I'll add 7 to both sides, and I'll get x is equal to 7. We're told to check our answers, so let's check 0 first. Well, we already did that. 0 squared is nothing. 7 times 0 is nothing. And yeah, 0 on the left side does equal 0 on the right. Now let's check this value of 7. Well, 7 squared. Now, you're going to be tempted to want to plug it into the factored form, but you could have made an error anyway along this path. So we have to plug it in the original equation. And 7 squared on the left becomes 49. And 7 times 7 on the right becomes 49. And that also checks out. So we'd be feeling pretty good there. I'm going to summarize what we did on this problem, but first I'm going to look back at the previous. The previous problem was already set equal to 0. They had done the work for us. It's easier for us to see that the zero product property tells us that either the left or the right side would have to be 0. When we looked at this one, it wasn't already set equal to 0. We had to recognize this as the type of problem that has a squared, which we know until we have set equal to 0, we can't really get very far. After we moved all of the x's to the left side, we were able to see that we could factor it. And then from factoring it, we realized that either the left or the right portion would have to be set equal to 0 to figure this out. Not many of these problems are all the same. And because of that, you're going to have a very way more open path to get there. Now this example looks a little nicer, but there's a coefficient or a constant out here in front of that 3. But really, 3 times 0 would be 0. So we could write 3n equals 0 for the left portion, but it doesn't really matter. And I wouldn't bother showing that I divide by 3, but really that is what's going on. I'd simply just jump to the next step and say n0 and be done with the left part, thanks to the zero product property. But that also means this value could be equal to 0 as well. So here's n plus 2 is 0. Solve it. And I'm going to have n as negative 2. And as a final step, I'm going to write n equals 0, comma, negative 2, summarizing both answers in the same step. Plugging 0 back in here, 0 times anything gives me 0. Plugging negative 2 in here, negative 2 plus 2 gives me 0, and that checks out as well. Since we didn't rewrite these as one answer, let's go back and fix that. Let me sit on that for a moment. 0, comma, 7. I don't put parentheses around these. Then it looks like an ordered pair. It's a list of 2 solutions. Don't put parentheses around them. All right. 7y squared minus 35d. Try this one on your own. Okay, it's already set to 0. I'm going to factor out 7y. That leaves me with a y here minus 5. But what value did you have here? I had a d. So on purpose, I threw one your way that you can't solve. Can't do. There's 2 variables. Just kind of a little trick, if you will. So let's rewrite this as one you can do. So let's write can do. Smiley face. Yay! We'll rewrite 7y squared minus 35 equals 0. But we're going to change d to y. Here we can factor out 7y, leaving me with y minus 5, where y would then be 0 or 5. Now notice that I jumped right to this one pretty quickly. Well, the reason I did is because there's not many steps involved in figuring this one out. I can just look at it and picture what y has to be. That's different from here, where picturing it requires more practice. But the more you do these, the more quickly you can end up at these final steps. And one more time, we don't write that as an ordered pair. Let's plug it back in. 7 times 0 squared is 0. 35 times 0 is 0. And 0 minus 0 gives me 0. Let's try 5. 5 squared is 25. Pull my calculator out. Times 7 is 175. And then 35 times 7 is also 175. And if we were to subtract those, that's how we'd end up. Okay, let's realize that these are the assigned problems. There's a lot of them. Maybe these will be more time-consuming because you'll be looking at them longer at the start to figure out how to go about them. And here's my note. Do not develop a shallow understanding of this chapter. It will be assumed as background knowledge moving forward. And when you get to the end of the chapter, there's going to be no explanation of what method to use to factor, to solve when you set these things to equal to 0. So make sure this feels all right. Because of the zero product property, we can now solve pre-factored problems and ones that we'd have to factor ourselves.